Hello, welcome to our presentation for March with Verde. My name is Rochelle and I am the Home Garden Program Manager, and I'm going to be sharing our March content with you. The topic that we are talking about this month is seed anatomy and germination. So please feel free to gather or print off any of the handouts that we sent or pull them up on your computer, and I'll be referencing those as we go through the presentation. So welcome. So an overview of our lesson today, we're going to start with an introduction and a review of February's content, just real briefly. Then we're going to go on to our nutrition topic, which is carbohydrates and fiber. From there, we'll do our garden topic, which is seed anatomy and germination. After that, we'll go over our climate change topic, which is to reduce and reuse. And then our climate change action step and activity will be a little different because we're not able to be there in person, but I will give you some ideas of things you could do on your own and ways to repurpose some containers with planting seeds at home. And then finally, we'll go over some announcements. So for February, think back to what we talked about. First, let's talk about MyPlate, the food pyramid. I don't know if you remember, we talked about the food pyramid, which was the old way of talking about food and health and what you need for your daily requirements. The new model, which has been the last 10 years or so, maybe since around 2012 or something, they've been using the MyPlate model. And this is a little more helpful because rather than saying quantities like the most to the least, where in the past it was carbohydrates at the bottom of the pyramid and fats and sugars at the top, and now it's taking a look at the whole plate. So approximately about half of your plate will be fruits and vegetables with a little bit more of the vegetables. Approximately half of your plate will be grains and protein with a little bit more on the carbohydrate or the grains. And then you also have your dairy. We also talked about landfills and how it's a problem for our environment and for our health and everything, increasing carbon emissions into the atmosphere, which are detrimental and causing the global warming that we're experiencing. And the reason for this is because when trash and even material that could be composted is compressed into a tight space, it's not able to get the air that it needs to break down. It's not able to have the small little decomposer critters, the insects and the bacteria and the fungi are not able to get in there and break it down. It doesn't have the moisture that it needs. And so it just sits there and it pollutes, and it actually produces CO2, carbon dioxide, or methane gas. And those are two major pollutants for our atmosphere. We also talked, you can see on the right of the screen, we talked about the elements of our compost pile. And so at the bottom of the compost pile, we have a layer of twigs and sticks. And the reason that this is important is because it helps aerate the bottom of the pile so that it has a little space for air to get in and flow. Because without the air, all the bacteria and the fungi will die, and all the little beneficial decomposers, the insects and beetles and worms, will not be able to survive. So after the sticks, we have our nitrogen layer, and this is going to be all your greens. So we have, yard clippings, we have food scraps from the kitchen, nothing with fat or grease or animal products, but plant-based food scraps, nothing with seeds that are going to regrow. We always say no weeds or seeds. And then you're going to alternate the green layer with which is the nitrogen producing material, with the carbon layer, which is the browns. So your cardboard, your paper, your dry leaves, any dry yard clippings that you might have, egg cartons, but you're going to want to tear it into small pieces for all of this. And so then you're going to go ahead and layer carbon, nitrogen, so greens, browns, and then ending with a layer of brown. And then about once a week, you're going to want to turn your pile. This keeps the airflow going. It helps mix it up so that the decomposers can access different parts of the pile and different nutrients and just get it all broken down a little more quickly. And then finally, you're going to want to check the moisture of your pile. If it's been real dry and sunny, you're going to want to probably add water to your pile. And if it's been raining, you're probably going to want to add some browns to absorb some of that moisture. And the way that you can tell if your pile has the right amount of moisture is if you pick up a handful of it and you squeeze and you have maybe 1 or 2 drops of water come out, that's really good. That means it has the right amount. But if it drips a lot, or if there's no water, then you know you either need to add browns if it's too wet, or add water if there's no moisture at all. So those are some things that we reviewed in February. And then finally, we have our types of soil. So these first 3, the sandy soil, the silt, and the clay, these are all inorganic, which means they do not have any living material in them. They don't have bacteria or fungi. They don't have the proper nutrients that are ideal for plant growth. However, the 4th type of soil, loam, is organic, meaning it has living material within it. And so it's going to have the bacteria, the fungi. It's going to have the beneficial decomposers, the worms, the bugs and beetles that are really important for breaking down material. It's going to have a real rich, earthy forest smell to it. And that's the best type of soil for growing plants. All right, so our nutrition topic is carbohydrates. And attached in your email where this presentation was sent, you should also have a worksheet handout called Total Carbohydrates. And if you want to pull that out now, I'm going to go ahead and go over it. We're going to talk about what is a carbohydrate. So following along in the first paragraph, carbohydrate is found primarily in plant foods. The exception is in dairy products, which contain milk sugars or lactose. There are several types of carbohydrate. So the first one is the sugars. So sugars are the smallest type of carbohydrate and include single sugars and those with 2 sugar molecules joined together. These are the quickest to digest. However, they have very little nutritional value for you, if any, other than just calories. Sugar alcohols are carbohydrates that chemically have characteristics of both sugars and alcohols. Starches are made up of many glucose molecules and linked together in long chains. And dietary fiber is made up of many sugar molecules linked together. But unlike starches, fiber is bound together in such a way that it cannot be readily digested. And there are 2 types of dietary fiber, soluble and insoluble. And we'll go over that in a little bit on the worksheet here. So where are carbohydrates found? Sugars are found naturally in foods such as dairy products, fruits, and vegetables. Sugars are also added to foods, as you know, and beverages for taste, for texture, preservation, and they are often found in foods like grain-based dairies, desserts, sugar-sweetened beverages, and sweet treats. Sugar alcohols are found naturally in small amounts in a variety of fruits and vegetables. Sugar alcohols are also commercially produced from sugars and starch and added as a reduced calorie sweetener to foods such as chewing gum, frosting, grain-based and dairy-based desserts, and sweets. Starches are found naturally in things like beans and peas. So for example, garbanzo beans, kidney beans, lentils, split peas, and grains such as barley, brown rice, corn, oats, and wheat, and vegetables such as carrots or sweet potatoes. Starches can also be added to foods during the processing or preparation to thicken or to stabilize them. And then finally, dietary fiber is found in beans and peas, fruits, nuts, and seeds, vegetables, and whole grain foods such as brown rice and whole grain breads, cereals, and pasta. So what do each of these carbohydrates do? So for sugars and starches, they are the body's main source of calories. Your body breaks down these carbohydrates into glucose. Glucose in the blood, often referred to as blood sugar, is the primary energy source for the body. Sugars are used to sweeten, preserve, and improve functional attributes of food. Sugar alcohols, their function is to provide a sweet taste with fewer calories per gram than table sugar, which is called sucrose, and are commonly used in place of sugar in food. Sugar alcohols also have other functions in food, including producing a cooling sensation in the mouth, adding bulk and texture to food, and helping retain moisture and preventing browning. Finally, the dietary fiber promotes intestinal regularity. This is a very important part of carbohydrates, is your fiber. It also helps prevent constipation. So fiber makes you feel full. It slows your digestion and the rate at which carbohydrates and other nutrients are absorbed into the bloodstream. So you're going to feel full longer. You're not going to get as many calories because the structure of the fiber is such that a lot of it ends up getting eliminated, but this is helpful because it kind of helps clean out your intestinal tract. And so, dietary fiber can also interfere with the absorption of dietary fat and cholesterol, which is good because those are things that, you know, you want healthy fats, but you don't want excess fats and you don't want excess cholesterol. So the fiber is there to help balance that out. On the second page of that worksheet are some action steps, and I would encourage you to go over these yourself and just have some practical tips of how you can monitor the correct amounts of fiber, the correct amounts of carbohydrates in your diet each day. And so take a look at the action steps. I also wanted to point out on page 1, this nutrition label right here. So you're going to see total carbohydrates on there, and it's going to tell you the percentage. But what you want to do is also look below, because it's going to tell you how much dietary fiber is in the food. And so this particular food has 55 grams of total carbohydrate and 6 grams of fiber. However, if you keep looking down, underneath the fiber are sugars, and it says 23 grams. If it were me, I would not choose something that was that high in sugar. It's, you know, because it has the nutrition label, it's something that's processed. And so the best thing that you can do to limit your added sugars is to shop the exterior of the grocery store, so around the outside where you have your fresh produce, your fresh breads and cheese and meats, and the center where you know, the cereals and stuff are. That's where most of your processed food is, and that's where they sneak in a lot of sugars. So just be careful of that. Be sure to check your nutrition label and read about the types of carbohydrates that are included there. All right, so let's talk about the basic anatomy of a seed. You don't have to memorize all of the terms that I'm going to be using here, but it helps to understand the basic structure and functions of the germinating seed and seedling. And germinate is just a word that means how it's going from a seed to growing into a plant. So right now I want you to look for your parts of a seed worksheet. So as I'm talking, you'll be able to go over that and label the parts of the seed. There'll be specific insight on the next slide, but just to have it ready to go here. Okay, so let's start by talking about what a seed needs in order to germinate, in order to start growing. Different seeds have different needs, and they can vary greatly as to how to best activate the seed to start growing. So for example, scarification is the process of like scraping, maybe with sandpaper or with something rough, the outside coating of the seed, the shell, in order to kind of break it down so that it's easier for the plant to come out and grow. And so an example of a seed that you might rough up on the outside with sandpaper or something would be like bitter melon, because it has a very tough seed. You also can soak seeds in water. This is great for larger seeds with hard coats like peas and corn, pumpkin, squash, sunflowers, lupine, which is a beautiful type of wildflower, beans. And then in addition to soaking and scarification, there's also burning, which is not something that we'll do, but it's just for your knowledge. Mostly this is with pine cones. So some pine cones only release their seeds when they're under extreme heat, for example, in a forest fire or something. So we won't be doing that type of seed germination, but just so you know, as another way. And then there's also fermentation. And so this would be, for example, like with a tomato seed. If you were to harvest the seeds from a tomato, an heirloom tomato plant from your yard, and we'll talk about heirloom in a little bit, but if you were to harvest the seeds from the inside of the tomato, you'll notice that the seeds have a clear little jelly-like coating around them. And this is really difficult to get off the seed. And so what you can do is a simple fermentation process where you put the seeds in a little bit of water in a cup, and you're going to cover it with a coffee filter and a rubber band. So you want air to be able to flow through there. That's why I suggest the coffee filter. And every day, or a couple times a day, you'll just swirl it around. And what is going to happen is the water and the tomato seeds are going to start to ferment, and that clear jelly coating is going to start to come off of the seed. And after maybe 2 to 3 days, you will see that the coating has come off and that the seeds have separated from that. So what you're going to want to do is put the seeds out, dump the excess water, put the seeds on a paper towel and dry them in the sun. And then once they're dried, they're ready to either be stored or planted. And so that's kind of how a tomato seed works, so with the fermentation process. So as you can see, different seeds need different conditions to germinate. So another thing that you're going to want to look for when you're preparing to plant your seeds is when to plant them. So different seeds have different requirements as far as how long they take to germinate. And we've provided an attachment here for you that basically says a schedule of when approximately to plant your seeds, and then as well as how long it takes for them to germinate. And this is important because some seeds might only take 2 weeks, other seeds might take 5 weeks. And so if you start your seeds too soon or too late, they may either be ready too soon to be able to be planted outside, it might still be too cold, or it might be too hot by the time you put them in the soil and they're going to suffer from the heat, because you want the plant to be stronger by the time the heat comes. So you also have to take into consideration the season, and if it's a particularly warm season, you might plant a little sooner. If it's very wet and rainy and cold, you might need to wait a little longer before you put them into your garden outside. So all of these conditions are going to help us know when to plant our seed and what it needs to best germinate. So it's also going to help you achieve the best outcome for the survival of the plant, the growth, and the productivity of your harvest and your the fruit that your plant produces. So now, as you can see on the screen, there's two types of seeds that I want to talk about. At the top of the graphic there, you can see that there are monocots. And then on the bottom half, we're going to talk about dicots. So these are two types of seeds, and you may find this information to be a little technical, but it's helpful because once you know what type of seed it is, it helps you to know the conditions in your garden that are best for the seed. So let's start with monocots. Monocots are simple in structure, more simple than the dicot. They contain one embryonic leaf, which is called a cotyledon. The leaf veins are usually parallel, so if you see the picture of the leaf on the chart there, the lines of the veins of the leaf are going to go straight, like you would see on a lily, corn, that type of thing. Other examples: garlic, onion, wheat, rice, asparagus, lemongrass. These all have the parallel veins of the leaf. The vascular bundles, if you were to cut the stem of the plant, you would see that they're kind of complexly arranged, not in a specific order. They're kind of clustered in groups and stuff. You're going to notice that the root structure is fibrous and kind of more ball-like. It's going to spread out rather than down. And that's important. That's one major thing about a monocot that you can note, because if you have a whole bunch of monocots too closely together, their roots are going to get all tangled and gnarled. They're going to be competing for nutrients, and you're not going to have as good of an output. Finally, you can also tell which type of seed it is by the number of petals on the flower. And this is a generalization, but in general, a monocot has flower petals in multiples of 3. So you can see the lily in this photo looks like it could be a tiger lily or some type of daylily, has 6 petals, and so that's telling you that it's a monocot. And the leaf will also represent that the parallel vein structure. So now on the lower half for the dicots, these are a little more complex in structure. They're going to have 2 embryonic leaves, and which is called a cotyledon. The leaf veins, as you can see in the example of this, it kind of looks like a maple leaf. It's going to be more net-like, more varied and not parallel as you see in the leaf above. Let's see, the vascular bundles, if you were to cut the stem and observe it, you would see that they are arranged in a ring. And the root, this is probably the most important part, I think, is that the root is going to have a taproot, which means it's going to have one main root that's going straight down into the soil. It means depth. And then it will have lateral side shoots from the root, but not in the same way as the monocots, where it's kind of a big web net ball of fibrous roots. The dicot is going to have the taproot that goes straight down, and so it needs that depth. If you stagger your monocot and dicots, then you have some plants that are going down deep and others that are going wide and kind of more shallow. And so you're going to be able to not deplete your soil of nutrients by varying where, some are going shallow, some are going deep. And so it's going to have a better result for your plants there. And then as you can see, the flower for the, I can't move my screen, the flower for the dicot is usually in multiples of 4 or 5. So I can't really tell. This looks like it could be a columbine flower, and it has 5 petals. So you can tell that that's another indicator that it's a dicot. Okay, so we're going to go ahead and go on. All right, so anatomy of a seed, which is also just the parts of a seed. We're going to be going over that right now. A seed is a living entity that serves as a bridge between generations of a plant. A seed contains the embryo plant and stored food. So within the seed is the genetic material that's going to say what the seed's going to be like, the conditions that it will thrive under. Seeds are actually quite amazing in that they can adapt over time and evolve to be best for the conditions and climate for which you're planting them in. So let's talk about the structure and the anatomy. So at first we have what is called the root structure, which is called the radicle. So you can see in your monocot seed on the top, the radicle, where that's located. And then as well on the dicot on the bottom, that seed. So that is, again, that's your root that's inside the seed. If you were to soak a lima bean or a corn seed or a pea, which we did try to do in one of our classes last month, if you cut it in half, you can see these little tiny structures inside if you cut it at the right angle. So that's kind of fun if you want to try that at home. Then we also have the stem, which is called the hypocotyl, and you can look on the chart here and see right next to the root, the radicle, is the hypocotyl, so just above it, which will become the stem, and you can see that on the dicot and then as well on the monocot seed on the top. You can see the leaves are called the epicotyl, and so the dicot, again, di means two, so the dicot has two embryonic leaves, and the monocot, mono meaning one, has one embryonic leaf. And then we've got the food source, which is called the endosperm in the monocot, and it's called the cotyledons in the dicot. So they do have a little bit of different names. And then the seed coat, interestingly, is called the Tesla. And then also interesting, every seed has a tiny little hole, sort of where that the radicle, where the root is, there's a tiny, tiny hole, and this allows water to get into the seed and for the seed to start expanding until it bursts. And once it bursts, the first thing that's going to come out is the root, called the radicle. The root in a monocot is going to just go straight down, and for the dicot, it's going to kind of arch down, because while it's arching down, it's going down, and then the hypocotyl, or the stem, is going to go up towards the sun. And as you can see on here, the embryonic leaves for both plants are not the true leaves, and they're going to wither and die, but the next set of leaves that comes out are the true leaves. So there'll be one for the monocot, one true leaf, and two true leaves for the dicot. So that's a little bit about the structure of your seed. Okay, so seed germination occurs when a mature seed is activated by the right conditions, such as water, soil, sunlight. For most seeds, water is the first step to activate the seed. So like I said, the water enters the seed through a tiny hole, and it's going to begin to swell, and the seed coat begins to soften and then burst open. Processes like scarification and soaking are just going to help ensure quicker germination, making it a little easier for more of your seeds to successfully germinate. The root structure, or the radicle, is the first structure to emerge and shoot downward into the soil. And then a hook-like structure, the hypocotyl, will reach up towards in search of the sunlight. As it grows, it's going to straighten out and reach towards the sun. So we can see that on the diagram on the right of your screen. You can see how the roots reach out to kind of a hook-like structure. They're going down, and then the hypocotyl, or the stem, is going to start shooting upwards. And you'll see that the embryonic leaves, which they have labeled as the cotyledons, those are going to wither away and allow the true leaves to emerge from there. And this particular seed, which looks like it's some sort of bean, is in the dicot family, and the way we can tell this is because it's going to develop a primary root, or a taproot, and then the lateral roots are on either side. You can also see on the left the diagram of just the life cycle of a plant, going from seed to the sprout to the adult plant. And then once the adult plant has finished its life cycle, before it dies, it's going to bloom. That's one of the last stages, is the blooming, because it wants to pass on its seeds. And so it's going to grow the fruit, which has the seeds on the inside, and then the whole process can start. So be sure on the previous slide that you took the time to fill out your worksheet on the parts of the seed. If you need to go back, pause the video and review that, please feel free to do that now. We're going to move on and talk about our climate change topic, which is about reducing and reusing. So let's take a few minutes to discuss a major contributing factor to climate change: mass consumption. So capitalism is the dominant economic practice in our culture today. Capitalism promotes private property, accumulation of wealth, competitive markets, and the voluntary exchange of goods. While some people feel this is a good model, it does have weaknesses. For example, the mass production of goods creates enormous amounts of waste that negatively impacts the planet. From pollution, such as landfills, air, water, to the exploitation of natural resources, so think rainforest being destroyed and cut down, the loss of natural habitats for animals and insects. So through these things, so capitalism is disconnecting us from the impact of our daily choices and our daily purchases. We're constantly updating our wardrobes, our electronics. We're using disposable items such as plates and forks and spoons, and we're consuming these goods at rates that are not sustainable or beneficial to our planet. So what can we do about this? As you can see on your screen, we've got the responsible waste management hierarchy. So this is the diagram on the left where the triangle is pointing downward. So at the top is our most desired tier, the widest tier, reduce. So by reducing, we can say no to refuse goods that we don't need. We can be content with less, not just accumulating stuff for the sake of accumulating it. So we're just, in general, we're generating less waste. We're reducing our consumption. In the yellow box, moving down, is the reuse. So as we reuse things, we can repair clothing that might have a hole or a tear in it. We can wash and clean things that have stains, or attempt to repair or fix devices or technology that breaks rather than just throwing it out and buying a new one. I think, society years ago used to, perhaps my parents' generation used to have this more of a mentality, or my grandparents' generation. The people of the Depression era, they were used to fixing things that broke and sewing holes in their socks and that type of thing. And we've really moved away from that to a more disposable culture where we have fast fashion, and you wear a shirt a handful of times and then it's stretched out, or it doesn't hold up, and so you throw it away and buy the next new one. And so what we can do is to reduce and then reuse things, repair things. So on the blue tier, moving down, is recycle. Recycling gets the most attention, but it's actually not the primary thing that we should be doing to help our planet. Recycling still creates waste. It still disconnects us from and doesn't hold us responsible from the amount of things that we consume. So we might justify buying bottled water because we can just recycle the bottles afterwards. But we're still depending on plastics and the processes to clean and repurpose and remelt it down are still using energy, are still producing carbon emissions, and take an impact on our planet. So if instead of recycling a plastic water bottle, we have a reusable metal bottle or a glass that we reuse when we go out and about. We are reducing the amount of waste in general, and that is much more preferable than to just recycle something. And then finally, I'm going to skip the recovery, but just go straight to the disposal. So that is the very last step that we need to consider when there's no other options. If it's not able to be repaired or reused in a different capacity, then the last choice is disposal, which will end up going to a landfill. So on the right, you can see there's the hierarchy of needs. So this one, like the preference, the base, the bottom of the pyramid is the most desirable. So you can see it says use what you have. So be content, use what you already have. If you don't have something that you need, borrow it. See if a neighbor has it, see if a family member has it, and borrow it, and then you can give it back. If it's something that you need longer term, maybe you'll swap for it. On Facebook and on other social media platforms, there's a lot of buy-sell swaps. There's free cycle websites where you have something that somebody else needs and they have something that you need and you swap. So even if it's like, I have 30 tomato plants and I only need 10, can I trade for your corn or for whatever it is that somebody else has? And so there's lots of ways to do that, and you can even set that up in your own neighborhood with your own community or circle of friends or church group or whatever type of community that you belong to, doing the swap. So then moving up, the next is the thrift store. I love thrift stores, and as I look at this chart, I realize I think I need to try harder to do more borrowing and swapping, or just being content with what I have, because while thrift stores are still good, there's still the cycle of purchasing and getting new stuff and kind of feeding into the system, even though it's not buying brand new. Then above that, if you can't find it at a thrift store, you can't borrow it or swap it, then you could make it yourself. And the reason that this is better than buying it brand new is because you're not depending on mass capitalism, not mass industrial processes. You're not feeding into the supply and demand. You might be using materials that somebody else made that you purchased, but you're not, when you, like, for example, when you buy an item of clothing off a rack, when you take that home, that's creating a hole that then the company is going to fill. They're going to say, oh, there's a demand for this, so we're going to refill that and have it available so that more people can have it. But if you're not buying that garment off the shelf, then the demand lowers and they're not going to make more of them. So that's kind of the logic behind that. So did you know, a little fact for you that I found, that clutter can actually increase stress and anxiety. Research has shown that working in cluttered spaces increases stress hormones and makes us more distracted and less productive. So it's time to reduce our consumption and reuse or repurpose what we already have. All right. So here's our action step. Was going to be germinating seeds in repurposed containers. Unfortunately, we're not meeting together, so I'll just give you some ideas of ways you could do this at home. As you can see on the slide, you can repurpose toilet paper rolls. If you fold the bottoms in, you can start your seed in there, and then once it's ready and big enough to go into the garden, which we're planning on doing planting around April, mid-April, so hopefully that timeline will still work. So you could take the toilet paper roll, it looks like they cut it in half, they folded up the bottom, they planted their seed, you can water it, and then once it's ready, you're just going to open the bottom so that the roots can get out, but you can plant the whole cardboard tube in the soil, and that's going to give the plant a little bit of protection from any critters that might try to damage the roots. but the roots will still be able to grow and lengthen. So that's one option. You also can start them in egg cartons, or even some people, as you can see in the photo, have done it in eggshells. The eggshell has nutrients that kind of give the seed a jump start. I would recommend, if you're going to plant that directly in the soil, to break open the bottom of the eggshell so that the roots can escape. The whole eggshells, or half eggshells, as you can see, that's going to take a lot of time to decompose. It will decompose and it will be beneficial to the soil. But you want to make sure that the roots have a way of escaping. You can also plant them directly into the carton there, or your egg cartons can be torn up and put in the compost pile. All of that is biodegradable. But then if you have things like plastic yogurt cups or plastic cups from different food items that you've purchased, you can reuse those as your pots for starting seeds indoors before you put them in your garden. And then the final way, as you can see, there's a way of using newspaper kind of in a tube similar to the toilet paper roll. And this is really great too, because you can just plant this directly in the ground. You want to, once again, open up the bottom to make sure the roots can get out once it's developed and has grown large enough to be able to plant in the ground. But the newspaper is going to decompose, and so that's kind of a natural way. Whereas if you use the plastic cup, you would want to empty, you gently tip it upside down, you let the plant fall out, and then you could reuse the cup again next year. Rinse it out and just save it. If you find a method that works really well for you each year, I'd say go ahead and keep using it. So a couple other things I mentioned earlier, be sure to check the planting schedule to see how many days until germination. The seeds that we'll be handing out and seedlings from Verde are going to have instructions. They're going to tell you seed depth. They're going to tell you how many days until it's germinated, and how many days until it's ready to harvest, or maybe not days, but what to look for when it's ready to be harvested. And so our hope is that we can stay on schedule and get you your seedlings by mid-April. But with the closures, we'll just have to. Okay, finally, so our announcements. So we have a campaign, a fundraising campaign going on for Verde right now. This is not required, it's not mandatory, but if you are able, we are asking supporters of Verde to give $20, and then to find 5 friends who can match your donation and also give $20. We're hoping that this campaign will be done by the end of March, and our goal was to raise $40,000. So it might be a little tricky. We've had, with the coronavirus and things, just the situation going on in our country. And so, but if you're able, if you can donate 20, that would be wonderful. If you can't, maybe you could just share our fundraiser with others and tell others about it. As you can see on your screen, 1 in 5 children in Santa Clara County, where we live in the Bay Area, they don't have access to affordable, nutritious food. So this is just one way that we all can pitch in just a little bit and make a big difference. All of the proceeds will go right back into the program to help more people have the opportunity to grow their own organic food. So as you can see, number 5, we did list the Seedling Festival on here. Unfortunately, it's canceled due to the coronavirus regulations and restrictions, so we will not be having that. We are hoping to have our planting days in April, but please be watching for more information on that. And then as far as the garden beds, they've been built. They're ready and waiting for you as soon as we have the okay to distribute. So most likely we will be distributing after April 7th, when the shelter-in-place ban has been lifted. So please feel free to email us, email Rita or myself, Rochelle, at valleyverde.org. If you have any questions, you can find us on Facebook and our website, www.valleyverde.org. And we'd be happy to answer your questions. Take care, and spend time with your families, and be safe.